Welcome students. Today we are going to start our part 3rd from lesson Language of Chemistry. Students, in this part we will learn what is meant by chemical equation. The chemical equation is the symbolic representation of a chemical reaction. In that chemical reaction we are using the symbols and formulae of the substances which are involved in that reaction. Students, after this point we have to learn about what is meant by reactants and what is meant by product. So which are the reactants? The reactants are the substances which is used as the starting material and react with each other. That are the reactants. And students, after this reaction the products are formed, that is as a result of reaction. So that substances are called as a product. Now students, one example I want to explain, that burning of coal in air. So this chemical reaction we will see that with the example. In this chemical reaction, how we will represent it? By the word equation also and by the chemical equation also. Carbon react with oxygen form carbon dioxide. Both reactants are the carbon and oxygen, and product is the carbon dioxide. Now students, our next topic is that the steps involved in writing chemical equation. So first step we will learn. First we have to write the symbols or the formulae of the reactants on left hand side. Left hand side we have to write down all the reactants, and students, we have to use the plus sign when more than one reactants are there. In between that reactants we have to give the plus sign. Second step, we are writing the symbols and formulae of the products also on right hand side. Again we have to use the plus sign also when the products are more than one. In between that we have to keep the plus sign. The third step about this writing in chemical equation, put the sign of an arrow in between the reactant and the product. So arrow sign is very important. And the fourth and important point is that the representation of the reactant and products are always in molecular form. It is not in the atomic form. Students, already we have learned about this concept. Atoms not having independent existence. Some atom may not having independent existence. That's why we have to use the molecular form. So these are the steps involving for the writing in chemical equation. Now students, consider some chemical reaction. So the first example for this chemical reaction is that reaction of lead monoxide and carbon, they react with each other and they are forming lead and carbon monoxide. Second example is that reaction between iron and sulfur on heating, it forms the new compound, that is the iron sulfide. For these two examples, if we will see that, if we will count the number of atoms on the reactant side and the number of atoms of the product side, the both are the equal. Both are the equal. The first example, lead monoxide. So lead atom is, number of atom is 1, oxygen atom is 1, then carbon atom is 1, so this on reactant side. And on product side you will see that lead and carbon monoxide, so number of atom of the lead is also 1, number of carbon is also 1, and the number of oxygen atom is also 1. Students, second example I explain, iron and sulfur. See the reactant side, both are the iron and sulfur are the reactants. Iron atom is also 1, sulfur atom is also 1. When they are forming the compound iron sulfide, that is iron is also the 1 atom and the sulfur is also the 1 atom. So students, from these two examples we will learn in that way, the number of atoms on reactant sides are equal to the number of atoms on product side. That is called as a balanced chemical equation. And students, the next example is that if we will see the reaction between hydrogen and chloride, that forming the hydrogen chloride compound. But we are not writing hydrogen and chloride in the atom formed. So H2 plus Cl2, it will form the HCl. So students, if we will count the number of atoms on reactant side and the product side, hydrogen atoms are 2, chlorine atoms are 2 on reactant side, and HCl, hydrogen atom is 1 and chlorine atom is also 1. So the total number of atoms of reactant side are not equal to the total number of atoms of the product side. That's why this chemical equation is called as a unbalanced chemical equation or skeletal equation. Again, some example I want to explain to you. Hydrogen and oxygen. So that forming the water molecule, that is also unbalanced equation because H2 plus O2, 2 hydrogen atoms and 2 oxygen atoms on reactant side. H2O, one molecule of water, is forming 2 hydrogen atom but 1 oxygen atom. That's why it is also called as a skeletal chemical equation. Now students, our next topic is that all chemical equation must be balanced in order to follow the law of conservation of mass. And students, what is the law of mass of conservation? In first lesson also we learn. It states that matter neither be created nor be destroyed. It transfer from one form to another form. So it is very important to balance the chemical equation. So our next topic is that the need for balancing chemical equation. So we have to make the balanced chemical equation means students, the number of atoms on reactant sides we have to get the equal the number of atoms on the product side, that we have to equal. Then the equation we called as a balanced chemical equation. So students, why we have to balance chemical equation? This is because the chemical reaction is just a rearrangement of atoms and the atoms neither be created nor be destroyed. Only it can be changing from one form to another form in that chemical reaction. Hydrogen and chlorine, H2 plus Cl2, it forms the hydrogen chloride, HCl. So if we want to balance the chemical equation, so the product side we have to multiply by 2, that HCl we have to write down 2HCl, so that we will get the balanced chemical equation. The first significance is that this chemical equation shows that which substances are taking part in chemical reaction and what product is obtained as a result after completing the chemical reaction. Second significance of chemical equation is that this equation shows the both number of atoms and number of molecules which are taking part in the chemical reaction. And the third significance is that it enables to calculate actual amount of the reactants and the products. We are able to calculate the atomic mass of the reactant side also and the product side also, which are involved in the reaction. But first we have to know the atomic mass of each element. And students, due to this chemical equation, that balanced chemical equation, makes the study of chemically universally standardized. And the first one for this topic is that if we will see that 2 calcium atoms react with 1 molecule of oxygen, it forms 2 molecules of calcium oxide. Calcium reacts with oxygen, it forming calcium oxide. And if we will see with the help of the monoatomic and diatomic, so 2 monoatomic calcium molecules react with 1 diatomic oxygen molecule, it forms 2 molecules of calcium oxide compound. And the next one, we will able to calculate the atomic mass of these reactants and product. Now students, I will explain these all things with the help of the example. The atomic mass of calcium is 40 atomic mass unit and the mass of oxygen is 16 atomic mass unit. For the above example, total mass of calcium taking part in the reaction is 2 into 40 is equal to 80 units. And for oxygen, it is 2 multiplied by 16, it is 32 units. total mass of reactants are equal to 80 plus 32 is equal to 112 units. The mass of calcium oxide formed is that 2 in bracket 40 plus 16 is equal to 112 units. So students, here 80 units of calcium combines with 32 units of oxygen and it produces 112 units of calcium oxide. So according to the law of conservation of matter or mass, the total mass of reactant side is equal to the total mass of the product side. Now students, the next topic is that how to balance a chemical equation. A chemical equation is balanced by the following step. The first step, we have to give that one example I am going to explain. Burning of magnesium in the presence of oxygen. So magnesium burns in oxygen, the product is the magnesium oxide. And the word equation is that magnesium plus oxygen, it form magnesium oxide. So formulae for the reactants are the Mg and O2 and the formula for the product is MgO. Therefore, the skeletal equation is that Mg plus O2, it forms the MgO. Now students, steps for balancing the chemical equation. The step first, count the number of atoms of each element on either side. So first we have to count the number of atoms on reactant side also and the product side also. Both we have to write down. Here magnesium atom is 1 and oxygen atoms are 2 on reactant side, and the product side magnesium atom is 1 and oxygen atom is 1. Therefore we can see there is an extra oxygen atom present on the reactant side. Now step second, multiply the product side by 2 because there are 2 atoms of oxygen present on the reactant side. So Mg plus O2, we will get to the 2MgO. Now students, magnesium is 1 atom, oxygen is 2 atom on reactant side. On product side, magnesium is 2 and oxygen is 2. Means now 1 extra atom of oxygen present on the right hand side. So steps third, multiply the magnesium atom on the left hand side by 2. So 2 magnesium plus oxygen, it will get the 2 magnesium oxide atom. So students, 2 magnesium oxide, these are the steps how to balance the chemical equation. There are the limitations of the chemical equation. Which informations we are getting for the chemical equation, but some informations are remaining to get by this chemical equation. The first one, physical states of the reactants and the products we not understood. Means students, the substances which are taking part as a reactant, that we state it is solid, liquid or gaseous. Or in product side, what products we are getting, it is in solid state, liquid state or gaseous state. The second one, the concentration of the reactant and the product. Third point, time taken for the completion of the reaction. Fourth one, the rate of which a reaction is proceed. What is the rate? The next one, heat changes during chemical reaction. Heat is absorbed or heat is evolved. Next one, conditions like temperature, pressure, then catalyst also involved in the chemical reaction. Next one, the nature of the reaction. The reaction is reversible or irreversible. So that's why students, how can a chemical equation is become more informative? The first point is that the physical state of the reactants and the products can be indicated by putting small s for solid, then second letter L for liquid, then second letter G for gas and AQ for aqueous state. Second one, evolution or absorption of heat during the reaction can be denoted by adding or subtracting by a heat term on the product side. Third point, temperature, pressure and catalyst can be indicated above the arrow separating the reactants and the products. Then fourth one, concentration of the reactants and products are indicated by adding the words dilute for dilution, concentration for concentrated before their formulae. And by sign, arrow or these both arrows, information about the reversible and irreversible reaction can be obtained. For example, nitrogen and hydrogen reacted with each other forming ammonia, and it is the reversible reaction. So we are able to show the two arrows for the reversible reaction. The reaction took place at a temperature between 400 to 500 degrees Celsius at a high pressure and between 200-900 atmosphere. So we are able to show the catalyst is iron and molybdenum act as a promoter which increases the efficiency of the catalyst. So upward arrow we have to indicating a gas is evolved. Then downward arrow indicate that a precipitate is formed. Then sign delta indicated heat is evolved or absorbed. So we have to use some sign for the making the our chemical equation more informative. So one example is there. Sodium chloride aqueous react with silver nitrate. It is also aqueous. It form silver chloride white precipitate and sodium nitrate. This is the aqueous. So we will show with the help of this sign and symbol. So students, in part 3rd we learn what is mean by chemical equation, what is mean by balanced and unbalanced or skeletal equation, and why it is important to balance the chemical equation. And after that we learn how to balance the chemical equation. And after that we learn about the limitation of this chemical equation. And after that how to become the chemical equation is more informative. So students, here we completed our part 3rd also and our lesson also, language of chemistry. Thank you.